there's a scene at the beginning of Lord of the Rings, The Two Towers, the movie, where Gandalf falls off the bridge of Khazad-dûm, but before he falls off, he drops his sword, and then it's many seconds later that he later falls off, and then at the beginning of The Two Towers, they show him falling and catching up to his sword, and I just couldn't enjoy the movie because, really, swords are dense metal and they're probably very aerodynamic. They probably have a much higher terminal velocity than a person. So if you dropped your sword off a bridge and then jumped off of it, you would never catch up to it. And I thought during the movie, oh, that's just wrong. I just couldn't enjoy the movie until I thought, well, one, they didn't say, but maybe Glamdring is made out of mithril, and as you know, mithril is a very strong but light metal, and so it might have a very low terminal velocity. And two, it's possible that wizards are just impervious to air resistance. And with these two things in mind, then I felt that I could enjoy the movies once again. And anyway, this is a typical type of problem that you would get in Chapter 2 with a lot of assumptions. 1, sword is made out of mithril. 2, wizards are impervious to air resistance. 3, Lord of the Rings takes place on Earth. Therefore, we know that Gandalf is accelerating downwards at 9.8 meters per second squared. Now, that last assumption might not be true, except there were, in the movie, apples, very recognizable Earth fruit. Like, no apples. Earth is the only planet known to humanity to have apples on it. Apples exist on Earth. All right, so I'm going to say acceleration of gravity is negative 9.8 meters per second squared. All right, the general strategy for these types of collision problems is to write an equation for one object that's going to collide with the other object, and that equation has to have final position and it has to be a function of time. And then we write an equation for the other object if the two objects are going to collide for the final position of the second object, and that other equation has to also be a function of time. And what we do then is set the final positions of each equation to equal to each other and solve for time, because what a collision is when two objects are at the same final position at the same time. So a collision is this wonderful synchronicity of time and space. So we need an equation with final position for each object, and we need an equation, and those equations have to be functions of time, because in order for things to collide, they must not only be at the same position, they must be at the same position at the same time. I'm going to start with Gandalf because we've already established that Gandalf his acceleration is negative 9.8 meters per second squared, and so I'm going to just arbitrarily say that Gandalf's initial position is going to be 0. So how we say that is for just Gandalf, we're going to say x naught for Gandalf equals 0. The acceleration of Gandalf is equal to negative 9.8 meters per second squared. And now that's an assumption. Now here's the other thing, is that when it says Gandalf falls off the bridge, an astute physics student immediately knows that when you fall off a bridge, your initial velocity is going to be 0. And what we would like in our problem is we want an equation for final position, and the equation has to have time in it, because our strategy is that we're going to set the equation for Gandalf's final position equal to the equation for his sword's final position. And so and they have to be at the same place at the same time for a collision to occur, for Gandalf to catch up to his sword. Alright, all these variables suggest only one equation, and let me put those aside, and the equation is going to be the second equation on page 21, namely x minus x naught equals v naught t plus 1/2 at squared. And I'm given that x naught is 0 and v naught is 0. Actually, I'm arbitrarily assigning Gandalf's initial position to be the 0 of the y-axis in this case, and because Gandalf is said to have fallen, then I know that his initial velocity is 0. So this equation is a little simpler, and for these types of problems, which are harder than the rest, I'm not going to have you on your homework or on the test make an algebraic solution first, but we will note that Gandalf's equation reduces to 1/2 at squared, and I'm going to say that's the position of Gandalf, who is a wizard, so that's going to be x sub w. Okay, so I have an equation for Gandalf, but in order for me to draw an equation for the sword, actually in order for me to devise an equation for the sword, I have to draw a picture. Alright, so I have to draw a picture of Gandalf and the sword at t equals 0. Otherwise I would get confused if I were doing it myself. And the critical thing is that in my first part, I initially assigned the x naught of Gandalf here to be 0. What that means is that now I can't assign the x naught of the sword also to be equal to 0. In fact, what I'm forced to do now that once I've chosen x naught of Gandalf to be 0, then clearly, since the sword is below Gandalf, the x naught of the sword has to be minus 100 meters. Right? I don't have a choice. Once I've said x naught of Gandalf was 0, the x naught of sword can't be 0 now. It has to be minus 100 meters. And it has to be minus 100 meters because the sword is below Gandalf and we are taking downwards as the negative direction. All right, the other good thing that I'm given for the sword is they tell me that the initial velocity of the sword is a constant negative 30 meters per second. All right, now when they say constant terminal velocity of negative 30 meters per second, they're actually telling me another thing. They're telling me that the acceleration of the sword, because the velocity is constant, is 0 meters per second squared. Now, that makes a problem quite a bit easier, because now that I know the acceleration is 0, there's a bunch of equations that I could use for the sword to find the position as a function of time of the sword. In fact, at least 3 of the equations on page 21, all the equations that have acceleration and x final in them would be good equations to use for the sword. Okay, so the equation I'm going to use is the same one I use for Gandalf, only because it's first on the list. So I'm going to use x minus x naught equals v naught t plus 1/2 at squared again. But the good thing of this equation is that the acceleration is 0. Now, incidentally, whenever you get acceleration is 0, you can still use these equations, but notice that when acceleration is 0, the velocity doesn't change. So the other equations would also work because v equals v final, v naught equals v by itself, which is initial velocity, equals final velocity, and both of them are equal to negative 30 meters per second. Right, so there's several equations that would still work in this problem. You could yeah, and you have your choice. But in this particular, so I just picked that one because it was the first earlier on the list. So that one becomes. Let me make these a little smaller so I have some room. So this is actually the position of the sword minus x naught, which is minus 100, equals minus 30 times t. So my equation for the sword is actually going to be, this is my equation for the sword. Notice that the two negative signs on this side cancel into positive, but then I move it to the right side of the equal sign, and so it becomes negative again. So this is going to be minus 30t minus 100. Now here I've dropped units because I'm looking ahead and I can see that this is going to be a quadratic equation, and so I'm just going to use quadratic equation and drop units right away. Alright, so I've made an equation for the sword. I've made an equation for Gandalf. Both of them are functions of t, and so my next step is I'm going to set them equal to each other and solve for t, and that should be when Gandalf catches up to the sword, because they'll be at the same position at the same time. And I'm just going to plug in Gandalf's acceleration here. So the position of the wizard is 1/2 times negative 9.8 meters per second t squared. This is also half of 9.8 is also known as negative 4.9. So the position of the wizard is going to be, or Gandalf, is negative 4.9 t squared, and that's going to be equal to the position of the sword. So I set these two equations equal to each other, and then I solve. So this is going to be equal to negative 30t minus 100, and you can see that's a quadratic equation. For this class, you need to know how to solve a quadratic equation. I realize that some of you may have calculators with a solve button that will also solve a quadratic equation, and if you know how to use the solve button and you can make it give you both roots of the quadratic equation, that's fair. However, what you can't do is make a graph of this equation and try to use the graph, because I found that most graphing calculators, when you just trace along the graph and find the zeros, they don't give you an accurate enough answer for actually a multiple choice test. It's actually happened that you had the accuracy on the graphing trace function isn't good enough for multiple choice tests, or probably even free response tests. All right, so you're going to have to know quadratic equation, or be able to use the solve button on your calculator to arbitrary accuracy. So let's review. To do quadratic equation, I need to get all the numbers on one side or the other side of the equal sign. So I add 30t to both sides, and I add 100 to both sides, and I write t squared first, t second, and the number without the t last. And then quadratic equation, the first one is letter A, the second coefficient is letter B, and the third coefficient is letter C. And quadratic equation for this is t equals minus b plus or minus square root of b squared minus 4ac, all divided by 2a. Alright, let me just make some room over here. So that tells me that t is going to be minus 30 plus or minus square root of 30 squared minus 4 times a, which is negative 4.9, times c, which is 100. That's 100. Oops, that's 100. And that's all over 2 times negative 4.9. Whoops, negative 4.9. Alright, so in other words, it's going to be minus 30 plus or minus, and I figured out what the square root, it's the square root of 2,860, all divided by negative 9.8. Alright, And square root of 2,860 is, so what I have is t equals minus 30 plus or minus 53.479, that's the square root of 2,860, all divided by negative 9.8. And then I can see that I'm going to get a positive and a negative answer. So I'm going to get t equals minus 30 minus 53.479 divided by minus 9.8, and that's going to be plus 5.95 seconds. Okay, so I think the collision time is 5.95 seconds, but I really should check my answer. So when I plug in 5.95 seconds to the equation for the sword, which was, remember, minus 30t minus 100, so if I plug in 5.95 seconds, I'm going to get minus 178.5 minus 100. For the sword at 5.95 seconds, I'm going to get minus 278.5 meters. And so for Gandalf, for the wizard, I've got minus 4.9 t squared. And if I plug in 5.95 seconds to t squared there, I also get minus 278.5 meters, right? So that's going to be the time when the wizard catches up to his sword. And here we'd be done with the problem, except I want to go a little bit further and talk about, well, I just picked the positive root, but what is the other root? There's going to be a negative t in this. What is that about? Remember back in the quadratic, I just arbitrarily picked the positive root, but notice you can see here that if I add minus 30 to plus 53.479, what I'll get is t equals 23.479 divided by negative 9.8, and what that'll give me is a negative 2.397 seconds. Okay, and what I want to talk about the negative root is that it also actually has physical meaning in this case. So in our problem, we have Gandalf starting out at t equals 0, and he's falling down, and we found out that 5.95 seconds later, he'll fall down, and he'll eventually, because he's accelerating and the sword is not, he'll eventually catch up to his sword at a positive 5.95 seconds later. And here, Gandalf starts with velocity equal to 0. But the equations don't know this, but it could be that before Gandalf just fell off the bridge here, what could have happened is Gandalf could have been flying upwards, reached his maximum velocity at the very top of the bridge, and then started falling. The equations are totally consistent with that situation. And notice that if Gandalf had been somehow being propelled upwards, reached 0 velocity, and then started falling, notice at 2.39 seconds before Gandalf reached the very highest height, he would pass his sword on the way up. And that's what this negative 2.397 seconds is before Gandalf fell. That's what the negative sign, before the problem starts. In fact, 2.39 seconds before Gandalf fell, it's also possible for him to pass the sword on the way up before he fell down, and then later on caught the sword on the way down. So in this particular case, this negative time actually does have a physical meaning. It could be if Gandalf was shot upwards, reached his very highest height with 0 velocity, and then fell downwards. Well, 2.39 seconds before he actually fell, he would have passed the sword as Gandalf was going on the way up. and the sword was going on the way down. So, interestingly enough, the negative time actually does have an interesting meaning a lot of times in physics.